China's space program is often described as a quest for prestige, science, or national pride. That is too small. Beijing is building an orbital architecture for power. Its lunar missions are not ornaments. Its space station is not a museum piece. Its satellite networks, launch sites, robotic probes, military space units, and commercial space firms form a single strategic machine. The purpose is not merely to reach orbit. The purpose is to make China harder to coerce, harder to blind, harder to isolate, harder to defeat. In the 20th century, sea power separated empires from continental states. In the 21st century, orbital power may separate rule makers from rule takers. The United States still leads in many decisive areas, but China is no longer chasing the space age from behind. It is using space as an instrument of grand strategy, and the contest is no longer theoretical. It is overhead. The baseline is simple. China's space program is not a standalone scientific project. It is a state instrument designed to serve the larger aims of Chinese national power. It supports military modernization, economic autonomy, technological prestige, alliance formation, regime legitimacy. Beijing's official language often sounds sterile. It speaks of peaceful development, national strength, economic value, and international cooperation. That language is diplomatic. It is also precise. Space is not a hobby in the Chinese system. It is part of statecraft. The American habit is to separate sectors. Civil space over here, military space over there, commercial space in another box, academic research somewhere in the attic, next to the Christmas decorations and unused congressional reports. China does not think that way. Beijing's approach is integrated. Civil missions generate prestige and technical competence. Commercial firms increase manufacturing depth and launch cadence. Military units study how to use space for targeting, command, communications, navigation, and battlefield awareness. Diplomatic initiatives convert space cooperation into influence, especially across the developing world. The whole structure is meant to produce comprehensive national power. That is the bluff. China is building space power as part of a bid for strategic independence and eventual geopolitical preeminence. This matters because orbital infrastructure is now the nervous system of modern war and modern commerce. Precision weapons depend on satellites. Financial networks depend on timing signals. Maritime trade depends on space-enabled navigation. Disaster response, weather forecasting, agriculture, telecommunications, missile warning, and military command all touch orbit in one way or another. A great power that cannot defend its space architecture is vulnerable. A great power that can threaten another state's space architecture possesses leverage. A great power that can build parallel systems can survive coercion. That is the Chinese project. The Beidou navigation system gives China an alternative to American GPS. The Tiangong space station gives Beijing a sovereign human spaceflight platform after exclusion from the International Space Station. The Chang'e lunar missions give China scientific credibility and operational practice beyond Earth orbit. The planned International Lunar Research Station gives Beijing a coalition-building device on the moon. And China's mega-constellation projects aim to give Beijing mass in low Earth orbit, even if launch capacity and satellite quality remain serious bottlenecks. This is not a mirror image of NASA. NASA sells the dream of exploration. The PLA studies the architecture of victory. Chinese industry builds capacity. The party state ties the parts together. That does not mean every Chinese scientist is a strategist in disguise. It means the structure around them converts technical achievement into national power. A lunar sample mission becomes a scientific achievement, a propaganda asset, a diplomatic card, a workforce training tool, and a proof of deep space competence. Chang'e 6 is the model case. In 2024, China returned the first samples from the far side of the moon. That was a scientific first. It was also a strategic signal. It said China could communicate across the lunar far side. It could operate a robotic mission in hard terrain. It could manage ascent from the lunar surface. It could conduct rendezvous in lunar orbit. It could return material to Earth. Those are not circus tricks. Those are building blocks for cislunar logistics. The real contest is not flags and footprints. The contest is architecture. Who builds the satellites? Who owns the ground stations? Who controls the standards? Who provides navigation? Who writes the rules for lunar resource zones? Who can replace lost spacecraft faster? Who can survive the first week of a crisis after jamming, cyber attacks, and kinetic threats begin? That is where China's program has to be understood. It is no longer asking, can China reach space? That question is stale. The better question is this: can China use space to alter the balance of power on Earth? The answer is yes. The remaining question is how far, how fast, and at what cost? Act 1, Subsegment 2, History and Precedent. During the Cold War, space was theater, laboratory, and battlefield preparation room. The United States and the Soviet Union used space to display ideological vitality. Sputnik was not merely a satellite, it was a metal sermon. It announced that Soviet engineering could cross the heavens before American political leaders had fully explained to the public why orbit mattered. The United States answered with Apollo. The moon landing was scientific, it was technological, it was symbolic. It said that American industrial power could organize capital, engineering, universities, contractors, military expertise, and public imagination toward an act of national greatness. China studied that history carefully. The Cold War taught Beijing that space accomplishment carries strategic weight beyond the technical act itself. A launch vehicle proves missile-adjacent competence. Human spaceflight proves systems discipline. Lunar exploration proves deep space, tracking, propulsion, communications, autonomy, and long-duration planning. A space station proves habitability, docking, life support, crew rotation, and orbital construction. Those are prestige goods. They are also hard power signals. Yet the modern contest differs from the Cold War in three ways. First, the old space race was bipolar. The new one is multipolar, but the central axis is American-Chinese competition. Russia remains dangerous in counter space and nuclear signaling, but Russia is no longer the industrial peer that the Soviet Union was. Europe has competence, but not unity. India is rising. Japan is capable. The Gulf states are buying access and prestige. Commercial firms now move faster than many governments, which is a polite way of saying some bureaucracies have the turning radius of a cathedral. Second, the old space race focused on spectacular firsts. First satellite, first human, first spacewalk, first moon landing. The new contest focuses on infrastructure, launch cadence, satellite replenishment, commercial manufacturing, data networks, Earth observation, relay systems, navigation, lunar logistics, space domain awareness, cybersecurity, electronic warfare resilience, ground segment hardening. In the old contest, the question was who could reach the moon? In this contest, the question is who can operate through a degraded orbital environment after the opening moves of a crisis? Third, the old space race had a cleaner public separation between civil and military narratives, even though the technical overlap was always present. Today, dual use is the default condition. The same satellite bus can support civil communications or wartime networking. The same launch provider can serve a weather mission one month and a military payload the next. The same AI-enabled ground processing chain can support disaster relief or target recognition. China's party state is built to exploit that dual-use character. The United States has a large and capable commercial sector, but it lives inside a legal, financial, and cultural system that often separates civil, military, and commercial priorities. That separation has strengths. It produces creativity and competition. It also produces friction. China's system produces different strengths. It can direct banks, firms, universities, provincial governments, and military-linked entities toward national priorities. That does not make it magical. It can also waste money with majestic confidence. The bureaucracy can make bad assumptions at industrial scale, which is one of mankind's more reliable talents. But when the Chinese state decides an area matters, it can create depth. That depth is visible in launch sites, satellite factories, lunar missions, spaceplane testing, and the expansion of commercial space firms. It is also visible in the way Beijing presents space as part of national rejuvenation. The message is domestic as much as foreign. Space achievement tells the Chinese public that the party has restored China's standing after the century of humiliation. That is regime legitimacy written in rocket exhaust. There is also a deeper historical pattern. Rising powers seek access to strategic commons, sea lanes, airspace, cyberspace, orbit. Established powers tend to describe those commons as open and rules-based, especially when they already dominate them. Rising powers tend to call for fairness, access, and reform, especially when they want more room to maneuver. No one should faint theatrically over this. Great powers often discover moral vocabulary near their material interests. It is one of diplomacy's oldest parlor tricks, usually performed with a straight face and a very expensive fountain pen. China's space diplomacy follows this pattern. Beijing speaks of peaceful use, shared benefit, and international cooperation. At the same time, China is building military space and counterspace capability. American and allied analysts assess that China is expanding systems that could threaten satellites through electronic warfare, cyber effects, directed energy, co-orbital systems, and kinetic means. There is no contradiction from Beijing's perspective. Peaceful use is the diplomatic frame. Strategic advantage is the state objective. That is the historical lesson. China watched the Soviet Union stun the world. It watched America win the moon. It watched GPS reshape precision warfare. It watched Desert Storm demonstrate space-enabled combat. It watched NATO exploit surveillance and communications dominance. It watched the US military become dependent on orbit. Then it drew the obvious conclusion. Space is not above geopolitics. Space is where geopolitics learned to look down. Act 1, Subsegment 3, Geography and Technology. To understand China's space program, we have to stop thinking of space as empty altitude. Orbit is geography. It has routes, choke points, high ground, parking zones, shadows, and crowded neighborhoods. Low Earth orbit is close, fast, useful, and congested. Medium Earth orbit supports navigation constellations. Geostationary orbit sits over the equator, where satellites match Earth's rotation and appear fixed over one region. Cislunar space stretches between Earth and the Moon, where future logistics, communications relays, lunar missions, and surveillance architectures may take shape. China is building across these layers. Low Earth orbit matters because it supports Earth observation, reconnaissance, communications, weather, signals intelligence, and mega constellations. A satellite in low Earth orbit moves quickly around the planet, which means any single spacecraft has limited dwell time over a target. The answer is numbers. More satellites mean more frequent revisit, stronger coverage, and greater resilience. That is why mega constellations matter. The American experience with Starlink in Ukraine showed the military value of proliferated commercial satellite communications. China noticed. One imagines Chinese planners did not respond by saying, "How interesting, let us leave that advantage to the Americans." Bureaucracies can be slow, but they are rarely that charitable. China's Guowang and Qianfan projects are attempts to build large, low Earth orbit communications networks. Both remain well short of their intended scale, but the direction is clear. Beijing wants mass in orbit. It wants redundancy. It wants national control over the networks that move data through war, commerce, diplomacy, and social management. That gap matters. China has ambition. It also has bottlenecks. A country can announce a constellation more easily than it can manufacture, launch, control, and maintain one. Satellite production is one part, launch cadence is another. Ground terminals, spectrum rights, onboard reliability, debris management, software control, and user adoption all have to work. A constellation is not a press release. It is an organism made of factories, rockets, chips, antennas, software, operators, insurers, regulators, and customers. The dragon needs a supply chain. China appears to be building that supply chain at speed. Its satellite factory capacity has expanded rapidly, and its commercial space sector is no longer a decorative appendage to the state program. It is becoming a reserve army of manufacturing, software, launch services, and specialized engineering. That does not mean the system is mature. It means Beijing is trying to create the conditions for scale before all demand fully arrives. That can lead to waste. It can also create latent capacity, waiting for rockets, doctrine, and missions to catch up. This is where geography returns. China's launch sites give it access to different orbital inclinations and mission profiles. Inland launch sites such as Jiuquan, Taiyuan, and Xichang have long supported national missions. Wenchang on Hainan Island gives China a coastal, lower latitude launch site better suited for heavy lift missions and large payloads, especially toward geostationary and deep space trajectories. Coastal launch reduces overflight risk for spent stages, which is a polite engineering phrase for fewer rocket parts landing near villages. A small courtesy from the sky gods. Heavy lift matters because cislunar ambition requires mass. The moon is not merely a destination, it is a proving ground for logistics, power systems, precision landing, resource claims, surface operations, and coalition management. China's Chang'e program has moved step by step through orbiting, landing, roving, sample return, far-side operations, and relay communications. Chang'e 6, with its far-side sample return, demonstrated a difficult chain of operations that few states could even attempt. The South Pole Aitken Basin is scientifically important. The lunar South Polar region is strategically important. Water ice, if accessible in useful quantities, could support life support, fuel production, and long-duration operations. Even before resource extraction becomes practical, presence creates influence. A state that maps, lands, builds relays, establishes habits, and brings partners into its lunar architecture can shape expectations before treaties catch up. That is the politics of first infrastructure. The same logic applies to navigation. Beidou gives China global positioning, navigation, and timing independent of GPS. In peacetime, that supports transportation, finance, agriculture, telecom, and consumer services. In wartime, it supports missiles, aircraft, ships, drones, ground forces, and command systems. Independence from GPS means independence from American denial. That is a sovereign shield. Then there is geostationary orbit. Geostationary orbit is prime orbital real estate. Communications, missile warning, weather monitoring, and strategic military links depend on satellites that remain fixed relative to the Earth. These satellites are expensive, hard to replace, and often strategically important. The state that can monitor, approach, interfere with, or defend assets there gains coercive options. This is why counterspace matters. China does not need to blow up every satellite to change a war. It can jam communications. It can dazzle sensors. It can spoof navigation. It can attack ground stations. It can corrupt data. It can threaten key nodes. Kinetic destruction is dramatic. Non-kinetic attack may be more usable. It offers ambiguity, deniability, and reversibility. That is the gray zone logic we will return to later. For now, the technical baseline is this. China is not building a space program in one orbit. It is building a layered architecture. Low Earth orbit for volume and sensing. Medium Earth orbit for navigation. Geostationary orbit for strategic communications and persistence. Cislunar space for prestige, science, and future rule setting. ground infrastructure for control, commercial firms for scale, military organizations for application. Seen separately, these programs look like a busy national space agenda. Seen together, they look like a theory of power. And that theory is cold, coherent, and very old. Control the routes, build the ports, secure the signals, shape the rules, train the operators, bind partners to your system. Deny the adversary the confidence that his own system will survive first contact. That is grand strategy in orbit. That is China's wager. And in the next act, we move from the baseline to the current theater. The satellites being launched, the industrial machine being built, the money behind it, and the quiet forms of conflict already taking shape above the atmosphere. Now we move from theory to theater. China's space program is no longer a portfolio of impressive milestones. It is an operating system. Satellites are going up. Crews are rotating through Tiangong. Lunar missions are building the technical ladder toward the moon's south polar region. Commercial launch firms are trying to break the old state monopoly on access to orbit. This is the current theater, and the first fact is simple. China now has a persistent human presence in orbit. Tiangong is not as large as the International Space Station. It does not need to be. Its strategic meaning comes from sovereignty. China owns it. China staffs it. China services it. China chooses its partners. China decides who gets access and under what terms. That is not merely science. That is diplomatic control in orbit. The station also gives China regular practice in crewed launch, docking, life support, logistics, extravehicular operations, and orbital maintenance. Those sound like technical categories. They are also national habits. A country that rotates crews into space learns how to manage risk, train specialists, build redundancy, sustain industrial rhythm, and respond when something breaks. And something did break. In late 2025, China launched Shenzhou 22 as an uncrewed emergency mission to Tiangong after damage to the Shenzhou 20 return capsule left a crew without its normal return vehicle. Reuters reported that the mission was prepared in 16 days and carried supplies, parts, and repair equipment. That is not a pleasant incident for any space program. It is also a useful stress test. Orbital programs reveal their maturity when the script catches fire in the projector booth. The lesson is not that China is flawless. The lesson is that China is learning how to sustain orbital operations under pressure. That matters. Human spaceflight is expensive. It is politically visible. It creates technical drag. It also builds national competence in areas that transfer into military and industrial space. Rendezvous matters. Docking matters. Life support matters. In-space repair matters. Emergency launch preparation matters. A space station is a machine. It is also a school. Below Tiangong, in low Earth orbit, China is trying to build scale. This is where the current theater becomes crowded. The United States has Starlink. China wants its own answer. Actually, it wants several answers. Guowang, often translated as the National Network, is the state-backed mega-constellation project. Qianfan, also called Space Sail, is another large, low-Earth orbit broadband system. The purpose is clear. China wants satellite internet capacity that is not dependent on American firms, American regulators, American launchers, American ground infrastructure, or American political decisions. It wants domestic capacity. It wants exportable capacity. It wants wartime capacity. It wants the network layer of orbit under Chinese control. This is not yet Starlink at Chinese scale. That distinction matters. There is a habit in Washington to treat every Chinese announcement as a finished capability. That is sloppy. Announcements do not move data. Renderings do not survive radiation. Factory tours do not create orbital coverage. But the opposite mistake is worse. It is also sloppy to dismiss Chinese projects because they begin unevenly. A great power does not need to build the final form in year one. It needs to create the pipeline, the workforce, the launch rhythm, the industrial incentives, and the doctrine that make the final form plausible. China is building the pipeline. Then there are reconnaissance and remote sensing systems. China has steadily expanded satellites for imagery, radar, electronic intelligence, ocean surveillance, communications, and positioning. These systems support the People's Liberation Army in the Western Pacific, especially where maritime targeting and long-range fires matter. The Taiwan Strait is the obvious case. The South China Sea is another. The Philippine Sea is another. A space architecture that can detect ships, track formations, relay data, support missile guidance, and preserve command links gives Beijing greater confidence in anti-access and area denial operations. This is the military meaning of the current theater. China does not need to match the United States satellite for satellite across every category tomorrow. It needs enough orbital support to make American intervention more dangerous, more confused, and more expensive in a crisis near China's coast. That is the near-term military problem. The long-term problem is larger. If China can create independent orbital networks, independent lunar access, independent navigation, and independent launch capacity, then Beijing reduces American leverage across the whole space order. Sanctions bite less when your supply chain is domestic. Coercion scares less when your infrastructure is redundant. Diplomacy changes when other states can plug into your system. The current theater also stretches to the moon. Chang'e 6 returned samples from the lunar far side in 2024, a first in space history. That mission showed far-side communication through a relay satellite, surface sampling, ascent from the moon, lunar orbit rendezvous, and Earth return. Those steps point toward Chang'e 7 and Chang'e 8, which are meant to support South Polar exploration and later infrastructure concepts. The larger political frame is the International Lunar Research Station, China's planned lunar base architecture with Russia and other partners. The moon is still harsh. The economics are immature. The timelines are uncertain. But the direction is plain. China is trying to make the lunar South Pole a place where Chinese standards, Chinese equipment, Chinese partners, and Chinese legal arguments arrive early. First arrival does not guarantee ownership. It does shape the argument. And in geopolitics, the first state to build the road often gets to name the toll booth. Act 2, Subsegment 2, Economics. Space strategy depends on money. That sentence sounds obvious, but it is often ignored because rockets make people poetic and budgets make them sleepy. Budgets win. Factories win. Supply chains win. Launch insurance, materials, chips, propellant production, ground networks, antennas, test facilities, and trained technicians win. A space program is not a flag. It is an industrial machine with a flame trench. China understands this. Its space economy is being built through a mixture of state direction, provincial competition, commercial firms, military demand, and national prestige. That mixture can be messy. It can also be powerful. China's commercial space sector has been growing for years, but the more recent change is the attempt to create scale. Launch startups are pursuing reusable rockets. Satellite firms are expanding production. Local governments are competing to host industrial parks, launch facilities, and manufacturing clusters. The commercial layer is not separate from the state layer. It is closer to a supervised garden. Some plants grow naturally. Some are watered with policy. Some are trimmed with shears. A few may be decorative shrubs pretending to be defense primes. The point is that Beijing wants capacity beyond the old state-owned giants. It wants a broader industrial base. That helps in three ways. First, it can lower costs. Second, it can increase launch and satellite production tempo. Third, it can create backup capacity if geopolitical pressure disrupts access to foreign components or markets. Strategic autonomy is not a slogan when it has factories attached. The satellite side is especially important. Recent reporting estimated that China has built or is building dozens of satellite factories with a theoretical output above 7,000 spacecraft per year, while actual launches in 2025 remained only in the several hundreds. That mismatch reveals both ambition and constraint. The ambition is industrial mass. The constraint is deployment. It is one thing to build satellites. It is another to launch them, control them, connect them to users, and keep the constellation functioning. The bottleneck is launch cadence. If China wants mega constellations, frequent replenishment, rapid replacement, and wartime resilience, it needs far more launch throughput. That means more rockets, more pads, more engines, more ground crews, more range capacity, more tracking networks, more failure tolerance. Because launch is not a gentleman's hobby. It is manufacturing under stress, chemistry under supervision, and mathematics praying nobody forgot a valve. This is where reusable launch becomes decisive. SpaceX changed the strategic economics of orbit by making launch cheaper, more frequent, and more flexible. That changed commercial space. It also changed military planning. China's leaders know this. Chinese commercial launch firms are chasing reusable systems because expendable rockets alone will make mega constellations painfully expensive. The country can use Long March vehicles to build early capacity, but long-term orbital mass needs cheaper launch. If China succeeds, the strategic picture changes. A China with low-cost reusable launch can deploy satellites faster, replenish losses faster, test more often, and support lunar logistics with more confidence. A China without it remains capable but burdened. Its plans become heavier than its rockets. Ambition has mass. Launch determines whether it reaches orbit. The supply chain question is equally important. Spacecraft require advanced electronics, radiation-tolerant components, sensors, propulsion systems, composite materials, optics, antennas, timing systems, and software. Some of those are vulnerable to export controls. American policy has tried to slow China's access to advanced semiconductors and related production tools. Those controls matter for space because satellites are computers, radios, sensors, and power systems wrapped in thermal blankets. China's answer is domestic substitution. The effort will not be clean. It will produce failures, delays, inefficiencies, and copied systems with suspiciously familiar silhouettes. But over time, the effort can still produce depth. This is where people often misread China. They ask whether Chinese systems are as good as American systems today. Sometimes the answer is no. But the strategic question is often different. Can China produce enough acceptable systems, replace them quickly, and improve them year after year? That is a more dangerous question. Quantity has its own diplomacy. It arrives without asking permission. Commercial space also gives Beijing a diplomatic export tool. A state that cannot afford its own space program can still buy access to Chinese satellite data, Chinese ground services, Chinese launch, Chinese navigation equipment, or Chinese training. This matters in Africa, Latin America, Southeast Asia, and the Middle East. For developing states, space cooperation can mean crop monitoring, disaster response, telecom coverage, mining surveys, maritime surveillance, weather forecasting, and national prestige. For China, those same projects create technical dependence, political goodwill, data relationships, and standards alignment. This is not charity floating upward in a red balloon. It is influence through infrastructure. If a country uses Chinese receivers, Chinese training, Chinese ground systems, Chinese satellite data, and Chinese financing, then China becomes part of that country's national nervous system. That is how space becomes economic statecraft. The United States still has major advantages. It has SpaceX. It has a massive commercial ecosystem. It has deep capital markets. It has leading universities, defense contractors, AI firms, and allied industrial partners. It has decades of operational practice. But China's economic strategy is not to beat America in every category at once. It is to close gaps, build alternatives, and create enough independent capacity that American pressure loses force. That is the economic theater. China is building the industrial base for a future in which space is no longer a narrow prestige sector. It is trying to make space a normal part of national power. Launch becomes logistics. Satellites become infrastructure. Data becomes leverage. Navigation becomes sovereignty. Lunar access becomes diplomacy. The quiet part is this. Once space becomes infrastructure, dependence becomes vulnerability. And Beijing has no intention of depending on Washington for the infrastructure of the next century. Act 2, Subsegment 3, Gray Zone. The most likely conflict in space does not begin with a satellite exploding on live television. It begins quietly. A signal weakens. A GPS receiver drifts. A satellite image arrives late. A ground station network behaves strangely. A command link drops during a military exercise. An object in orbit moves closer than expected. No one claims responsibility. No one fires a missile. No one declares war. That is the gray zone, and it is where China's current space posture becomes most dangerous. Kinetic anti-satellite weapons receive the most attention because they are dramatic. China's 2007 direct ascent anti-satellite test created thousands of pieces of orbital debris and became one of the clearest demonstrations that Beijing could physically destroy satellites in low Earth orbit. But kinetic attack is blunt. It creates debris. It invites retaliation. It leaves evidence. It risks escalation. Great powers prefer tools that can bruise without leaving fingerprints. That is why electronic warfare matters. Jamming can interfere with satellite communications, radar, or navigation. Spoofing can feed false positioning, navigation, or timing data into receivers. Uplink interference can disrupt the path from ground control to satellite. Downlink interference can block the path from satellite to user. The beauty of jamming, from the attacker's perspective, is ambiguity. Was it hostile action? Was it local interference? Was it weather? Was it a technical fault? Was it a poorly maintained system held together by optimism and procurement forms? Ambiguity slows response. That delay is the value. Cyber operations add another layer. Satellites depend on ground stations, mission control systems, software pipelines, cloud environments, update mechanisms, user terminals, and data processing chains. The satellite in orbit may be the glamorous object, but the ground segment is often the softer target. A cyber attack against a ground network can corrupt data, interrupt service, steal tasking information, alter telemetry, or degrade command systems. The target may not be the spacecraft. It may be the people and networks that tell the spacecraft what to do. This is especially important for commercial systems. Commercial satellite providers move fast. They serve civilian users, military customers, governments, and private firms at the same time. That gives them scale. It also broadens the attack surface. A military satellite may sit inside hardened procedures. A commercial satellite network may have vendors, contractors, remote support tools, shared software dependencies, customer terminals, and supply chain exposure. The castle has many doors because it was built as a shopping mall. Directed energy is another concern. Lasers can dazzle or blind optical sensors, depending on power, geometry, atmospheric conditions, and the target system. Dazzling may be temporary. Blinding may be permanent. The political appeal is obvious. A state can interfere with satellite imaging during a crisis without producing debris and without crossing the psychological threshold of blowing up a satellite. The Secure World Foundation's 2026 Counterspace Report tracks counterspace capabilities across co-orbital, direct descent, electronic warfare, directed energy, and cyber categories. That spread is the point. The modern counterspace problem is not one weapon, it is a menu. Co-orbital activity is even more delicate. Satellites can approach other satellites for inspection, servicing, repair, refueling, or removal. Those are legitimate missions. The same proximity operations can also create fear. A satellite that can inspect may also interfere. A satellite that can service may also grab. A satellite that can dock may also disable. Intent is hard to read in orbit. Distance is deceptive. Warning time can be short. Attribution can be slow. And commanders on Earth may have to decide whether a maneuver is harmless, coercive, or the opening move of an attack. That is a dangerous decision space. It rewards suspicion. It punishes delay. It can turn technical ambiguity into strategic panic. This is where deterrence becomes difficult. Cold War nuclear deterrence centered on visible forces, known thresholds, and catastrophic retaliation. Space deterrence is foggier. Many attacks can be reversible. Many effects can be hidden. Many targets are dual use. Many systems serve both civilian and military functions. Destroy a communication satellite, and the harmed users may include soldiers, banks, hospitals, ships, farmers, airlines, and ordinary citizens watching a weather map. Dual-use systems make every escalation ladder slippery. Like polishing stairs in a palace. Majestic, yes. Sensible, no. China can exploit this uncertainty. So can the United States. So can Russia. So can any state with enough technical skill and a taste for trouble. The issue is not that China invented gray zone space conflict. It did not. The issue is that China's grand strategy gives gray zone tools a clear role. They can weaken American confidence before a crisis. They can complicate coalition response during a crisis. They can degrade targeting, communications, and logistics during conflict. They can test thresholds without forcing immediate war. The most dangerous scenario is not a clean Pearl Harbor in space. It is corrosion. A pattern of incidents, probes, interference, close approaches, cyber intrusions, and legal claims that slowly normalize Chinese presence and pressure. Each incident remains below the threshold of war. Together, they change the operating environment. That is gray zone strategy, not victory in a single blow, advantage by accumulation. For the United States and its allies, the answer cannot be panic. Panic makes bad doctrine. The answer is resilience. More satellites, better hardening, faster replenishment, clearer thresholds, allied data sharing, cyber defense of ground systems, electronic warfare discipline, commercial integration with military planning before the shooting starts, and enough offensive capacity that Beijing knows interference will not be free. Deterrence in space cannot rest on exquisite satellites alone. Exquisite systems are powerful, but they are also tempting targets. A porcelain sword may be beautiful. Nobody should bring one to a knife fight in the dark. China has studied the American way of war. It has seen the dependence on satellites. It has seen the power of precision. It has seen the fragility beneath the elegance. And now it is building the tools to exploit that fragility. That is the current theater. Deployment, economics, gray zone pressure. China is not waiting for a future space race to begin. It is already shaping the operating environment. In Act 3, we widen the lens. Beijing's view, Moscow's shadow, the American coalition, and the game theory of escalation when the battlefield is above every capital on Earth. To understand China's space program, we have to see it from Beijing's side of the table, not sympathetically, clearly. Chinese strategists look at the United States and see a power that built the modern space order around its own advantages: GPS, missile warning, global communications, reconnaissance satellites, weather systems, precision timing, commercial launch, deep space prestige, allied interoperability. From Beijing's perspective, this is not neutral infrastructure. It is American power made orbital. And American power, in Beijing's view, is the principal obstacle to Chinese national rejuvenation. That phrase, national rejuvenation, is not decorative rhetoric. It is the ideological center of Xi Jinping's project. It says that China is returning to greatness after humiliation, weakness, foreign intrusion, and internal disorder. Space fits that story perfectly. It is modern, it is visible, it is hard, it is prestigious. It is technical proof that the party can organize the nation toward a grand objective. A lunar landing, a space station, or a far side sample return is not only a scientific result in Beijing's domestic narrative, it is evidence of restoration. Restoration is powerful politics. A regime that claims to have restored the nation must keep producing symbols of mastery. The moon is an excellent symbol because it has no opposition party, no labor union, no dissident newspaper, and no provincial governor asking for subsidies. It sits there in the sky, serene and expensive, waiting to be made useful. But prestige is only the surface. At the military level, Beijing sees space through the problem of American intervention. The Chinese Communist Party's central security nightmare is not an American invasion of mainland China. It is American military intervention near China's maritime perimeter, especially in a Taiwan contingency. To fight the United States near the first island chain, China needs to find, track, target, communicate, navigate, and coordinate under pressure. That means satellites. Space enables the kill chain. If China can see carrier strike groups, track aircraft movements, support long-range missiles, preserve command links, and protect its own navigation signals, then the cost of American intervention rises. If China can degrade American space support through jamming, cyber attack, dazzling, co-orbital pressure, or limited kinetic attack, the American military becomes slower, blinder, and more cautious. That is not abstract. That is the operational logic behind space power in the Western Pacific. From Beijing's view, this is defensive. That is important. Most great powers describe their own expansion as defensive. The British Empire defended sea lanes it happened to control. The Soviet Union defended revolutionary security across half of Europe. The United States defends a rules-based order whose rules are oddly comfortable for Washington. China says it is defending sovereignty, territorial integrity, and national development. The United States sees coercion. Both can be true at the level of perception. That is how security dilemmas work. One side builds capability to feel safer. The other side sees that capability and feels less safe. The second side responds. The first side points to the response as proof that its original fears were justified. The result is an arms race with excellent footnotes. Space is especially vulnerable to this pattern because intentions are hard to read. A rendezvous and proximity operation can be servicing practice. It can also be attack rehearsal. A satellite inspection system can protect orbital assets. It can also threaten an adversary's assets. A lunar relay network can support scientific missions. It can also create the communications layer for future strategic presence. A mega-constellation can connect rural users. It can also support wartime communications and targeting. Dual-use technology turns every explanation into a negotiation. Russia's view is different. Moscow no longer has China's industrial momentum. It still has nuclear weapons, counter space experience, deep space heritage, launch knowledge, electronic warfare skill, and a strategic culture comfortable with disruption. Russia sees space as one of the remaining arenas where it can still impose cost on stronger adversaries. It cannot outbuild the United States. It cannot outbuild China. But it can threaten, jam, spoof, interfere, signal, and destabilize. That makes Russia dangerous in a different way. China wants to climb. Russia wants to prevent falling. Those are different motives, but they can cooperate. The International Lunar Research Station is the most visible example. China leads the industrial and programmatic side. Russia contributes heritage, political alignment, and selected technical ambitions. China's space agency said in 2025 that 17 countries and international organizations, plus more than 50 research institutions, had joined the China-initiated ILRS framework. That number does not make the ILRS equal to Artemis. It does show Beijing's coalition strategy. China is not merely going to the moon, it is bringing a guest list. Russia also gives China a useful strategic echo. Both powers criticize American dominance. Both reject a US-centered order. Both support a more fragmented international system where Washington has less ability to set rules alone. In space, that means competing legal interpretations, competing lunar partnerships, competing technology standards, and competing norms around military behavior. The Secure World Foundation's 2026 Counterspace report tracks a widening set of counterspace capabilities across 13 countries, including co-orbital systems, direct descent weapons, electronic warfare, directed energy, and cyber. That matters because the battlefield is no longer theoretical. The toolkits are real. The doctrines are forming. The crisis pathways are visible. China and Russia do not need identical goals to create a shared problem for the United States. They need overlapping dissatisfaction. They have it. Beijing wants room to rise. Moscow wants room to disrupt. Both want a space order where American leadership is constrained, diluted, or bypassed. That is the adversary view. The United States sees deterrence. China sees encirclement. Russia sees survival through menace. The result is not misunderstanding. The result is competition between rival maps of the same sky. Act 3, Subsegment 2, the Coalition. The American answer to China's space strategy is not America alone. It cannot be. The orbital domain is too large. The industrial base is too complex. The diplomatic contest is too broad. The moon is too expensive. The threat surface is too wide. Coalition is not a decoration. It is the strategic center. The United States has an unmatched advantage in alliances. NATO, Japan, South Korea, Australia, Canada, Britain, France, Germany, Italy, India in selective alignment. The Gulf states in practical cooperation. Commercial firms with global reach. China has scale. America has networks. Networks win when they are disciplined. They become committee-shaped fog machines when they are not. The Artemis Accords are the diplomatic centerpiece of the American Lunar Coalition. As of April 23, 2026, Jordan became the 63rd signatory, according to NASA. The Accords commit signatories to principles such as peaceful exploration, transparency, interoperability, emergency assistance, registration of space objects, release of scientific data, and deconfliction of lunar activities. That is the public frame. The strategic frame is larger. The Artemis Accords are an attempt to create a rules-based coalition before the lunar economy matures. That timing matters. Rules written early become habits. Habits become expectations. Expectations become legitimacy. Legitimacy becomes power wearing a suit. China understands this. That is why the ILRS matters. The contest is not merely over where astronauts land. It is over whose procedures become normal, whose safety zones are accepted, whose data standards are trusted, whose communication systems are installed, whose logistics chains are used, whose financing brings new states into the architecture. Lunar governance will be shaped by infrastructure before it is settled by lawyers. The lawyers will arrive later with rolling suitcases and tragic confidence. American coalition strength begins with interoperability. NATO militaries train together. US, Japanese, Australian, British, Canadian, and European systems often share doctrine, procedures, and communication habits. That gives the United States a major advantage in crisis response. But space stretches this advantage. Allied satellites can provide additional sensing, communications, launch sites, ground stations, and regional knowledge. Allied territory can host sensors. Allied firms can build components. Allied militaries can share data. Allied universities can train specialists. Allied agencies can support science missions that build public legitimacy. In orbit, no ally is small if it owns a sensor, a ground station, a launch site, or a vote. Japan matters because it sits at the edge of the Western Pacific problem and has advanced space capability. Australia matters because of geography, ground stations, surveillance, and deep defense ties. Europe matters because of scientific depth, satellite manufacturing, launch ambitions, and regulatory influence. Britain and France matter because they are nuclear powers with military space programs and expeditionary habits. Canada matters because of robotics heritage and NORAD-linked warning. India matters because it is a rising space power with lunar success, low-cost mission credibility, and strategic friction with China. None of this assembles itself. Coalitions have problems. They have budget delays, industrial protectionism, classification barriers, export controls, incompatible systems, political changes, public fatigue, legal constraints, and, because mankind likes to amaze future archaeologists, they also have meetings about meetings. The American coalition can defeat itself through paperwork before China even has to jam anything. That is why the coalition must become operational, not ceremonial. There are 4 practical requirements. First, shared space domain awareness. Allies need to know what is in orbit, what it is doing, and when behavior changes. That means sensors, data fusion, common reporting channels, and confidence in attribution. Second, resilient communications. Military forces cannot assume clean satellite links in a crisis. They need alternate pathways, commercial backups, hardened terminals, anti-jam methods, and training under degraded conditions. Third, rapid replenishment. If satellites are disabled, replacements must move fast. That requires launch capacity, standardized payloads, responsive manufacturing, and pre-planned contracts. Fourth, political thresholds. Allies need to discuss ahead of time what kinds of interference count as hostile action. Waiting for a crisis to define thresholds is like writing a fire code after the cathedral roof catches flame. The United States also has to integrate commercial space without pretending commercial firms are magic. SpaceX changed the economics and military relevance of low Earth orbit. Starlink showed that commercial constellations can matter in war. But commercial firms have shareholders, customer bases, regulatory exposure, export rules, liability concerns, and brand risk. They cannot be treated as uniform formations with better websites. Commercial space is a force multiplier. It is also a governance problem with antennas. China's system can direct commercial firms more easily. America's system can create better firms. That is the trade. The American task is to make the best parts of commercial speed usable for national defense, without smothering them under procurement moss. That means pre-crisis contracts, clear legal authorities, cybersecurity standards, war-gamed service continuity, agreements for data sharing, plans for indemnification and replacement, and sober expectations about what private firms will do when their satellites become targets. The Allied coalition also needs narrative discipline. China will present its space program as inclusive, peaceful, anti-hegemonic, and open to the developing world. The United States cannot respond with a lecture and a logo. It has to offer concrete benefits. Weather data, disaster response, agricultural monitoring, training, launch access, scientific participation, communications support, student pathways, transparent rules. Grand strategy is not won by saying rules-based order, as if the phrase itself dispenses medicine. States join systems that solve problems. If America wants partners, it must bring tools, not slogans. The coalition contest is therefore practical. The Artemis Accords give Washington a diplomatic framework. Allied militaries give Washington operational depth. Commercial firms give Washington speed and scale. Universities give Washington talent. Capital markets give Washington risk tolerance. But these advantages have to be organized. China's strength is direction. America's strength is distributed competence. The question is whether distributed competence can be made coherent before Beijing's directed system creates facts on the ground, or rather, facts on the regolith. That is the coalition problem. And it leads directly to the hardest issue in space strategy: deterrence. Because coalitions are useful only if they can prevent war, absorb attack, and respond without stumbling into escalation. Act 3, Subsegment 3, Game Theory. Space deterrence is hard because space is full of ambiguity. Weapons can look like tools. Tools can look like weapons. A satellite can fail naturally. A cyber attack can look like a software problem. Jamming can look like interference. A close approach can look like inspection. A laser dazzling event can leave no crater, no smoke, and no corks. War in orbit may begin as an argument about whether war has begun. That is the game theory problem. Classic deterrence depends on three things: capability, credibility, communication. You need the ability to punish or deny an attack. The adversary must believe you will use that ability, and the adversary must understand the threshold he is being warned not to cross. Space complicates all three. Capability is often classified. Credibility is uncertain because the targets may be dual use. Communication is difficult because thresholds are vague. What is the red line? Jamming? Spoofing? Temporary dazzling? Permanent damage? Cyber intrusion into a ground station? A co-orbital satellite moving too close? The destruction of one military satellite? The destruction of a commercial satellite serving military users? Every answer creates risk. If the threshold is too low, normal friction becomes a crisis. If the threshold is too high, adversaries learn they can bite small pieces without being punished. That is salami slicing in orbit, a phrase that sounds absurd until one remembers that modern statecraft is often conducted by men in suits arguing over slices. China can exploit threshold uncertainty. It can probe. It can interfere. It can test Allied response. It can create incidents that are individually tolerable but collectively corrosive. This is especially useful in a Taiwan crisis. Before any blockade, strike, or amphibious operation, Beijing could try to degrade American and Allied sensing, communications, or navigation through reversible methods. Jamming near the theater, cyber pressure against commercial providers, dazzling of imaging satellites, spoofing of maritime or aviation signals, legal claims about foreign reconnaissance support, public accusations that American satellites are escalating the crisis. The objective would be to slow decision-making, split the coalition, raise insurance costs, complicate targeting, create doubt, buy time. Time is a weapon when the political clock favors the attacker. The United States faces a hard response problem. If it retaliates too aggressively, it may escalate a crisis into a wider war. If it does not respond, it may teach Beijing that gray zone pressure works. If it responds only in kind, it may accept the battlefield China prefers. If it responds outside space, it widens the conflict. There is no clean answer. There are only better and worse trade-offs. Deterrence by punishment says, if you attack my space systems, I will impose costs on you. Deterrence by denial says, if you attack my space systems, it will not help you enough. In space, denial may be more credible. Resilience is deterrence. If American and Allied forces can keep operating after jamming, cyber attack, dazzling, or satellite loss, then China gains less by striking first. That changes Beijing's calculation. The best satellite defense may be proving that losing satellites does not end the war. This means the future deterrence architecture has to be layered. Proliferated constellations, hardened exquisite systems, commercial backups, allied data sharing, terrestrial alternatives, airborne relays, navigation backups, cyber-secure ground stations, electronic warfare discipline, rapid launch, pre-planned public attribution, and offensive options held in reserve. That last point matters. A purely defensive space posture invites testing. A purely offensive one invites arms racing and panic. The strategic answer is controlled ambiguity backed by visible resilience. The adversary should know attacks will fail to produce decisive advantage. He should also know that serious interference will bring consequences. He does not need to know every detail. Deterrence sometimes works best when the enemy can see the gate, but not the dog. There is also a nuclear shadow. Space systems support nuclear command, control, communications, missile warning, and strategic situational awareness. Interference with those systems can be interpreted as preparation for a larger attack. That makes counterspace escalation uniquely dangerous. A strike intended to degrade conventional operations could be read as an attack on strategic warning. A cyber intrusion into satellite control could be read as preparation for nuclear blinding. A co-orbital maneuver near a missile warning satellite could trigger fear far beyond the immediate technical event. In space, the ladder of escalation may be bolted to the nuclear ceiling. This is why norms still matter. Not because norms make great powers gentle. They do not. Norms matter because they create expectations. They help identify abnormal behavior. They give allies a shared vocabulary. They help neutral states judge aggression. They reduce the chance that every maneuver becomes a panic. But norms without capability are sermons. Capability without norms is menace. The United States needs both. China will also use legal and diplomatic arguments. It will accuse the United States of militarizing space. It will present Chinese initiatives as peaceful. It will frame American coalitions as exclusionary. It will use developing world partnerships to argue that China represents a fairer order. Some of this will be propaganda. Some of it will resonate. The United States should not assume that every country hears American leadership and immediately feels wonder in its bones. Many states hear costs, conditions, lectures, and sanctions. China knows this. That is why the game theory is political as much as military. A crisis in orbit will be fought through signals, law, media, markets, insurance, diplomatic forums, commercial contracts, and classified military channels. The first state to explain the crisis credibly may shape the coalition response. The first state to restore service may win trust. The first state to overreact may lose support. The first state to appear weak may invite more pressure. This is a contest of nerves. And nerves are not built during the crisis. They are built before, through exercises, through doctrine, through allied planning, through public thresholds, through commercial contracts, through redundant architecture, through leaders who understand the domain before the domain starts breaking. The worst time to discover space strategy is during a space attack. That would be a very expensive seminar. So the game theory of China's space program is this. Beijing wants enough capability to deter American action, enough ambiguity to probe below the war threshold, enough resilience to survive American pressure, and enough diplomatic reach to prevent the United States from defining the rules alone. Washington wants to preserve access, deter attack, keep allies aligned, defend commercial systems, and prevent China from turning orbital infrastructure into coercive leverage. Russia hovers as a spoiler, a partner to China in some arenas, and a danger in its own right. The result is a multipolar contest in which the most important moves may be small: a ground station agreement, a lunar relay contract, a constellation launch, a cyber intrusion, a safety zone dispute, a navigation outage, a satellite maneuver in geostationary orbit. Great power competition in space will not always look like a rocket launch. Sometimes it will look like a clause in a standards document. Sometimes it will look like a delayed data feed. Sometimes it will look like silence. That is the majesty and danger of the domain. It is vast enough to inspire wonder. It is technical enough to hide intent. It is important enough to invite conflict. And it is fragile enough that one bad week could change the strategic balance. In Act 4, we move from diagnosis to estimate. The most likely trajectory over the next 3 to 5 years, the lower probability shocks that could bend the future, and the final strategic judgment on China's space program as an instrument of grand strategy. Now we come to the estimate, not the slogan, not the press release, not the fever dream in which every Chinese rocket is a dragon and every American committee is a wounded eagle clutching a briefing binder. The estimate. Over the next 3 to 5 years, the most likely trajectory is steady Chinese expansion across low Earth orbit, cislunar operations, commercial launch, satellite manufacturing, military space support, and diplomatic coalition building. China will not overtake the United States across the entire space domain in that time frame, but it does not need to. Its near-term aim is narrower and more practical. It wants to make American power less decisive near China's maritime perimeter. It wants to make Chinese forces less dependent on foreign space systems. It wants to create enough orbital redundancy that American sanctions, export controls, or wartime interference cannot paralyze Beijing. It wants to bring more countries into Chinese-led space arrangements. It wants to build enough lunar momentum that China becomes a rule shaper before the moon becomes economically mature. That is the likely path, not domination, accumulation. In low Earth orbit, China will keep building out large communication constellations. The early deployments will probably remain uneven. Launch bottlenecks, satellite reliability, user terminal production, spectrum management, and system testing will slow the clean march from announcement to reality. But the direction will hold. China saw what proliferated satellite communications did in Ukraine. It saw the operational value. It saw the political value. It saw the embarrassment of depending on a foreign billionaire in a war zone, which is a very modern sentence and therefore slightly cursed. Beijing will want its own version, not a copy in every detail, a sovereign substitute, a Chinese system that can serve domestic markets, support military operations, expand influence abroad, and reduce exposure to American-controlled platforms. In remote sensing, China will continue expanding its ability to monitor the Western Pacific. That means more optical imagery, more synthetic aperture radar, more maritime surveillance, more electronic intelligence, more data fusion, more rapid tasking, more ability to support long-range fires. The military value is obvious. A state that can find ships and relay targeting data can threaten ships. A state that can threaten ships can complicate intervention. A state that can complicate intervention gains coercive room before a crisis begins. This is the practical link between space and Taiwan. The contest over Taiwan is not only about amphibious ships, missiles, aircraft, and submarines. It is also about orbital sensing, communications, timing, and targeting. If Beijing can hold American forces farther away, degrade their coordination, and compress their decision time, then space has helped China before a shot is fired. The best weapon is sometimes the one that makes the other side hesitate. In cislunar space, China will push toward the next Chang'e missions and the International Lunar Research Station architecture. The lunar South Pole will remain the central theater because it combines scientific value, symbolic value, and possible resource value. The timelines will be slower than propaganda suggests. The engineering will be hard. The economics will be immature. But China does not need a fully functioning lunar economy in 5 years to gain advantage. It needs continuity, mission after mission, relay after relay, partner after partner, map after map, landing after landing. In geopolitics, continuity itself becomes evidence. It says the state can plan beyond election cycles. It says the state can deliver. It says partners can attach themselves to a moving train, even if the dining car is mostly slogans and freeze-dried noodles. The United States still has extraordinary advantages: reusable launch, commercial dynamism, deep capital, allied networks, scientific institutions, operational heritage, a private sector that can move with terrifying speed when the incentives line up. But China's advantage is state direction over long periods. The next 3 to 5 years will therefore be a race between American distributed competence and Chinese directed accumulation. America will often move faster in specific technologies. China will often move more deliberately across national objectives. America will build magnificent tools. China will build parallel systems. America will set market pace. China will set strategic requirements. One side improvises brilliantly. The other side plans heavily. History has room for both. It is rude that way. The most likely result is not Chinese supremacy. The most likely result is a more contested space order. More Chinese satellites, more Chinese lunar diplomacy, more Chinese commercial firms, more counterspace pressure, more allied concern, more American investment, more orbital congestion, more legal disputes, more gray zone incidents, more dependence on commercial space systems that were not designed for great power war, but will be dragged into it anyway. That is trajectory A steady hardening of space competition. A Chinese program that remains imperfect but increasingly broad. An American coalition that remains superior but increasingly pressured. A space environment that becomes less permissive, less clean, less predictable, and more central to every major crisis in the Indo-Pacific. No single event defines this trajectory. That is the point. It happens through accumulation. A satellite launch here, a ground station agreement there, a lunar mission, a constellation test, a military exercise, a cyber probe, a diplomatic signature, a commercial contract, a launch failure, a recovery, another launch. The future does not always arrive as thunder. Sometimes it arrives as paperwork attached to a payload fairing. Act 4, Subsegment 2, Trajectory B. The high-impact risks are different. They are less likely. They are also the events that could change the strategic environment fast. The first risk is a major counterspace incident during an Indo-Pacific crisis. Not necessarily a spectacular satellite shootdown. Something more ambiguous may be more plausible. A widespread jamming event. A cyber attack on a commercial satellite provider. A dazzling incident against an imaging satellite. A close approach in geostationary orbit. A data corruption event affecting military planning. A navigation disruption near Taiwan or the South China Sea. The danger is not only the technical effect, the danger is interpretation. Was this a local action, a central order, a test, a warning, a mistake, preparation for attack? The first hours would matter. And the first hours are exactly when information would be least clear. In a crisis, military commanders would want certainty. Political leaders would want options. Commercial firms would want legal protection. Allies would want attribution. Markets would want reassurance. The media would want a villain before the first telemetry team had finished drinking cold coffee. That is a dangerous mix. If the United States responds weakly, China may press harder. If the United States responds sharply, China may escalate. If allies doubt the evidence, coalition unity may crack. If the public does not understand the domain, the entire crisis may be reduced to childish metaphors about space wars, which will please headline writers and punish everyone else. The second risk is a debris-generating event. This could come from a deliberate anti-satellite test, wartime attack, collision, failed proximity operation, or uncontrolled breakup. Space debris is not dramatic in the way a missile explosion is dramatic. It is worse in some respects. It lingers, it spreads, it threatens unrelated spacecraft. It can make certain orbital regimes more dangerous for years. Debris is shrapnel with a long memory. A major debris event involving Chinese, American, Russian, or commercial systems could trigger legal disputes, insurance shocks, satellite losses, and military suspicion. It could also affect ordinary services, communications, navigation, weather, remote sensing, financial timing, aviation, maritime tracking. The public usually notices space infrastructure only when it stops behaving. Then everyone becomes an expert for 3 days, which is how civilization tests its patience. The third risk is a lunar governance clash. This sounds distant. It is not. The first serious dispute may not involve mining. It may involve safety zones, landing rights, communications interference, access to polar illumination areas, or claims around scientifically valuable terrain. The Artemis Coalition and the Chinese ILRS Coalition may both describe their actions as peaceful, transparent, and lawful. Both may accuse the other of exclusion. Both may claim they are protecting operations. Both may insist they oppose sovereignty claims while creating practical zones of control. That is how great powers behave when the law is underdeveloped and the terrain matters. They avoid saying empire. They prefer coordination mechanism. History is full of bayonets wearing nicer labels. The fourth risk is commercial entanglement. Commercial satellite networks are now part of military planning. That creates a hard question. When does a commercial provider become a military target? If a private constellation supports military communications, targeting, or intelligence, an adversary may treat it as part of the conflict system. But if that same constellation also serves civilians, international customers, emergency responders, and neutral states, striking it carries wider consequences. Dual use does not blur the battlefield, it smears it. This is especially dangerous because commercial firms operate across jurisdictions. A cyber attack on a company may pass through third countries. A satellite service may support multiple governments. A ground station may sit on allied territory. A data center may be commercial property. An outage may hit civilian users before military users. This gives states room to pressure each other through indirect methods. It also creates escalation pathways that no war plan fully controls. The fifth risk is overconfidence. This may be the most human risk. China may overestimate its ability to degrade American space systems. The United States may overestimate the resilience of its own architecture. Allies may overestimate American protection. Commercial firms may underestimate wartime targeting. Military planners may underestimate political hesitation. Political leaders may underestimate technical ambiguity. Every war begins with someone believing the machine will behave. Then the machine introduces itself. Overconfidence in space would be especially dangerous because losses may be hard to replace quickly. A destroyed ship can be seen. A downed aircraft can be counted. A disabled satellite may be one node in a hidden architecture whose loss becomes clear only when other systems begin to fail. The battlefield is invisible to the public, technical to the operators, classified to the commanders, and politically explosive to the leaders. That is a perfect environment for mistakes. Trajectory B, then, is not one scenario. It is a family of shocks. An ambiguous counterspace incident, a debris-generating event, a lunar governance clash, a commercial satellite attack, an escalation spiral driven by overconfidence and poor attribution. Each is lower probability than steady competition. Each could bend the strategic future. The best response is preparation before the shock. Clear allied thresholds, public communication plans, technical attribution capacity, commercial wartime agreements, ground station cyber defense, anti-jam training, backup navigation, responsive launch, distributed architectures, crisis hotlines, and political leaders who understand that the first report from orbit may be wrong. The phrase fog of war was coined for Earth. Space will add its own version. Call it orbital haze, cold, technical, silent, and thick enough to hide catastrophe until it is already moving. Trajectory B is the warning. The sky can become a battlefield before the public understands it has become infrastructure. Act 4, Subsegment 3, Summary and Sign-Off. So what is China's space program? It is not merely a national science program. It is not merely a prestige campaign. It is not merely a military project. It is not merely a commercial sector. It is an instrument of grand strategy. It allows Beijing to pursue 5 strategic objectives at once. First, military modernization. China needs space to support long-range precision warfare, maritime targeting, battlefield awareness, command and control, navigation, timing, and communications. Second, strategic autonomy. Beidou, Tiangong, domestic launch, satellite manufacturing, lunar missions, and Chinese commercial space all reduce dependence on systems that Washington can influence. Third, diplomatic influence. Space cooperation lets China offer services, prestige, training, data, and infrastructure to states that want access to orbit without entering the American strategic camp. Fourth, regime legitimacy. Space achievement tells the Chinese public that the party is restoring China's greatness. Fifth, rule shaping. By entering cislunar space early, building coalitions, setting technical habits, and creating practical infrastructure, China can influence the rules before the rules become settled. Those 5 objectives reinforce each other. That is why the program matters. A satellite constellation is also a military support layer. A lunar mission is also a diplomatic signal. A space station is also a sovereignty platform. A launch site is also industrial policy. A navigation system is also national independence. A commercial company is also latent state capacity. China's genius here is not that every piece is perfect. Its genius is that every piece can be made to serve the larger design. The United States should not panic. Panic is a poor strategist. It sweats through its suit and forgets the map. America remains ahead in many decisive areas: reusable launch, commercial space, deep science, allied reach, military experience, capital formation, software, operational flexibility. The United States has extraordinary advantages if it organizes them. That last phrase is the problem: if it organizes them. American space power is immense but scattered. Chinese space power is less mature but directed. The central question is whether American and allied distributed competence can remain faster, more resilient, and more coherent than Chinese state-directed accumulation. That is the contest, not whether China plants a flag, whether China builds a system. The correct American response has to be practical. Build resilient architectures, harden ground systems, treat cyber defense as space defense, expand responsive launch, integrate commercial providers before crisis, train under degraded conditions, share space domain awareness with allies, clarify thresholds, keep the Artemis coalition useful, not ceremonial, offer developing countries concrete space benefits instead of speeches wrapped in diplomatic upholstery, invest in cislunar capability, and above all, stop treating space as an inspirational background image for conferences. Space is infrastructure. Space is logistics. Space is targeting. Space is diplomacy. Space is deterrence. Space is commerce. Space is prestige. Space is command. The romance is real. So is the math. China's leaders understand that the next world order will not be shaped only by aircraft carriers, trade routes, semiconductor fabs, and currency flows. It will also be shaped by orbital systems. The state that can see farther, communicate longer, navigate independently, replace losses faster, and bring partners into its architecture will have greater freedom of action on Earth. That is the whole point. Space power does not float above terrestrial politics. It descends into them. It shapes wars, alliances, sanctions, supply chains, resource claims, weather models, shipping lanes, financial timing, disaster response, and national myth. China is using space to make itself more sovereign, more capable, more influential, more difficult to coerce, and eventually, if the architecture matures, more capable of coercing others. That is what grand strategy looks like when it learns orbital mechanics. The United States and its allies still have time. They have better tools in many categories. They have stronger partners. They have commercial speed. They have accumulated experience. But time is not an ally by default. Time serves whoever uses it. China is using it. Mission by mission, factory by factory, launch by launch, agreement by agreement, orbit by orbit. The mistake would be to judge the Chinese program only by its current gaps. Those gaps are real. Launch cadence is constrained, mega constellations are immature, commercial firms are still developing, cislunar economics are uncertain. Some state-directed investment will be wasteful. Some announcements will outrun reality by a wide and theatrical margin. But great powers do not become dangerous only when they become flawless. They become dangerous when their direction is clear, their resources are serious, and their rivals mistake imperfection for weakness. China's space program is imperfect. It is also coherent. That combination should focus the mind. Here is the final estimate. Over the next 3 to 5 years, China will not displace the United States as the dominant space power. But it will narrow the gap in selected areas, expand its diplomatic reach, harden its military support architecture, increase gray zone pressure, and push cislunar competition from symbolism toward infrastructure. The result will be a space domain that is more crowded, more contested, more militarized, and more politically important. The United States will remain ahead if it acts like a coalition leader with industrial seriousness. It will lose ground if it acts like speeches can substitute for launch cadence, resilience, and operational planning. The heavens are not waiting for a policy memo. China's space program is an instrument of grand strategy because Beijing understands a hard truth. The state that organizes the high ground does not merely watch the world. It changes the terms on which the world moves. That was true at sea. It was true in the air. It is becoming true in orbit. And so the contest above us is not a side story. It is one of the main theaters of 21st century power. Cold, technical, silent, majestic, and already underway. This has been Gene Botkin with Orbital Estimate. End transmission.